with what is color. So color starts somewhere. Where do you think color starts? Where does it begin? Type it in the chat box if you have a thought. Where does it start? Anybody have any thought? Light, Brittany. Yes, I love that. Light reflections, Catherine. Beautiful. Yes. Light. Yeah. You guys you got it. Here's the thing. Color begins with white light. And white light comes from rain and light. Ooh, Amanda, we're going to get to that. Rain and light. I love it. So it comes from the sun. White light comes from the sun. And all white light is energy in the form of a wave. So it comes down in an energy wave. Now, here's the thing. This white light is not just white. It's actually made from individual light waves. Look familiar, you guys? Yeah. What does it look like to you? Anybody seen that in the sky before? It's a rainbow. And the white light has individual colors, and each color or each wave has a color to it. It also has a different energy. Some of them are higher energies and some of them are lower energies. Like red is a low energy. Blues and violets are high energy, short, high waves. So when they travel together, it's white light. So in order to see color, we have to split it, don't we? If we don't split it and they travel together, guess what? It's just a white light. So in order to see color, we have to split the white light. So, okay, great. So color starts with this energy wave, and we know in order to see a color, we have to split the white light. Well, how does that split happen? How does color happen? And here's how it happens. White light comes down. It hits an object. Could be my hair. It could be my sweater. It could be the wall. And that object has something in it. It's called pigments. Pigments are little light absorbers. Now, based on that object, each object has a different set of pigments. And those pigments will, when this light hits it, it will absorb some, and some of them it won't absorb. Whatever it doesn't absorb bounces off the object. Is everybody with me so far? White light comes down. It has pigments, light absorbers. Depending on what pigment is in that object, some of those light waves will be absorbed and some will bounce off of it. When that happens, does the white light split? Type it in the chat box, yes or no. When it comes down and hits an object that has light absorbers, some gets absorbed and some bounces off. Yes, the light wave that bounces off, we call that reflection. That is color. Color is the wave that doesn't get absorbed. It gets reflected. Is everybody with me on that? Let's put it into an example. So this right here is an object. We know that the white light splits because we can see something, can't we? We see color. In order to see color, we have to split the white light. So when I think about this object, and I think about all the colors that come from that white light, what is the wave that remained on this object? Type it in the chat box for me. What remained? Blue. Blue remained. Color is the wave that bounces off and remains. So when I look at this object, everything else got absorbed but blue. Does everybody catch that? Let me repeat that. So all the white light comes down, right? And we know blue was meant to bounce off. Yes, Shannon. So it's counterproductive. When we look at this object, would you think that the light that got absorbed would be blue? Does anybody feel like that's what your brain would like to think? Yeah. Yeah. It's actually the opposite. Whatever we see is what bounced off and remains. Color is the light that remains, that bounces off, that reflects. Let's try another one. This object right here. So we know white light hit it because we can see color. Color happens when there's a splitting, right? So what color remains on this object? Type it in the chat box for me. Violet. Yes. Whatever you see is what bounced off the object. That's what remains. Color is light reflection. What happened to all the other waves? They got absorbed, so you can't see them. They got subtracted. The color you see bounced off. The colors you don't see got subtracted. Let's try another one. This one right here. All right, here comes my white light. Remember, it's all together, so it's white, right? So I know I see color. So did the wave split? Yes or no? Yeah, we know it split. All right. So this is the counter. You guys get that part. The part that's counterintuitive is the next part. The next part is when it splits, some of these get absorbed and subtracted. If it's subtracted, you will not see it. Are you with me? So what you see is what remained. What light wave remained on this block? Yes, Brittany got it. So here's what Brittany said. Yellow is reflected and everything else got absorbed. Absorbed means subtracted. You can't see it. Does that make sense to everybody? It's like counterintuitive. You think it absorbed yellow, but it didn't. It reflected yellow. Color is light reflection. What didn't get subtracted? Good? Mary, how you doing? I got my eye on you. I'm like, you good? You got it? And listen, it'll take a minute to process. If you've been thinking the other way, now you're thinking a new way. So you're unlearning and learning all at the same time. Good? All right, so color is white light that gets absorbed or reflected, right? So whatever gets reflected is color. In order to have color, the wave has to split. Whatever gets absorbed is subtracted. Whatever bounces off is reflected, is color. Color is what reflects. Okay, now it is kind of counterintuitive, but when you start to work with color, it helps to make sense, yeah? So let's talk about this. What happens in this scenario? What happens when white light hits this? What do you think? Does the wave split? Type it in the chat box for me. No, it doesn't. Yes, you guys, you got it. No, it doesn't. It doesn't split. So when I don't split something, that means I can't see color. No split, no color. If I split, meaning some gets subtracted and some gets absorbed, I'm going to see color. And color is what gets reflected. So here's the deal. White light comes down, hits an object that's white. And guess what it does? The whole thing comes down and it bounces right back off. Why doesn't anything get absorbed? What's the thing that absorbs things? Pigment. Yeah. White objects, no pigment, no light absorbers. So all of the waves come down at one time. They don't split. They bounce right back off together. Kind of like this right here, gray hair. Guess why gray hair looks gray? It comes down. Is there pigment in the gray hair? No, no pigment. So it's going to literally bounce right back off. So this is a great little visual. Here's my little pigmented hair strand. Do you see color in a pigmented hair? Everybody see color? Yes or no? Yeah. Here's a gray hair. Do you see pigment? No. So is there going to be a splitting of the wave? No, no pigment, no split. You got it. All right, let's talk about this one. Oh boy. So what happens with something that's black? The wave comes down, all absorbed. So Brittany says all absorbed. So here's the question. Does the wave split? Type yes or no in the chat box. Does the wave split with a black object? Shannon says no. Catherine says yes. Okay, you guys ready? Remember, in order, if it splits, I see color. If it doesn't split, I don't see color. Guess what it does? It absorbs all of them. So if I absorb all of them, did the wave split? No, no splitting. It all came down together and went in the object together. No split. White, there's no split. It all came down and it bounced right back off. White has no pigment, and black has a pigment that absorbs all of them at the same time. Does that make sense to everybody? All right, are you ready for the next one? Because this is the one that we use a lot in the hair world. We're gonna kind of get to a point of like, why are we even talking about this? What about gray? What happens with gray? Does the wave split? Give me a yes or no in the chat box. So I got yeses, I got no's. All right. So let me show you what happens with gray. Here's a cup. And here's a cup. This cup is going to be black. All right. So black, I'm going to do this really fast for time's sake. All of these are pigments. Because remember, pigments are what absorb the light, yes? So this white light comes down onto a black object and all of it gets absorbed, doesn't it? Yeah, so it doesn't split. So there's so many pigments and it absorbs so much light, it looks really deep and dark, called black. No split. What happens with gray? All right, this one is gray. These pigments are the same pigments as the black. Brittany, yes. Okay, so here's the deal. Same pigments. Remember, different pigments absorb different things. Because these pigments are the same ones as black, are they going to absorb all the light? Will they absorb all the light if they're the same pigments as this one right here? Yes, they will. They will. But what's the difference between these? Brittany said it earlier. Concentration is a lot less, isn't it? It's a different level. This is a deeper level. This is a lighter level. So here's what happens. The white light comes down and these will absorb all the pigments, right? So the rest of them, there's not a ton of pigment. So the rest of it, some will get all absorbed and then the others will bounce off just like white light. So we have some, what do you know about gray? It's a lighter version of what? Black. The only difference between black and gray is it's the same pigment. It will absorb the light the same way. There's just a lot less of it. Gray is just a lighter version of black. Black doesn't split, white doesn't split, and gray doesn't split, meaning we don't see a color, a warm or cool color, do we? Is everybody with me on that? Yeah, let me show you. So someone said it's the center of the color wheel. Brittany, beautiful. Let me show you guys this. Thank you, Alicia. Beautiful. What Alicia just did for you guys is she split my screen between me and the demo screen. This right here, hopefully everybody can see a screen that has lots of little objects on it. We're going to go back and forth between me and the demo screen. So if you cannot see the demo screen, give us a shout out. So what I'm showing you here, do you see black? You can't see it. So Brittany, you might have to change your view. Like if you're in gallery view, you might have to go to speaker view or vice versa. Does that make sense, Emily? Okay. Let me know when you got it. Okay, perfect. All right, so here we have black. Black, I want you to think of black as level 1. It's got the most concentration of pigment, right? And then we have white at the very top. White has no pigment, 0. And we know what happens when there's no pigment. The light bounces off and doesn't split, it stays white. Anywhere in between is just a lighter version of black, meaning the pigments get less and less and less. But it's all the same. No splitting of the wheel when it comes to black, no splitting here and no splitting here. Is everybody with me? Thumbs up if you're with me. Y in the chat box if you get that. Yes. Cool. Yes. All right, so here's the thing. Gray, black, white, because there's no split, no color, they're called achromatic. Achromatic means no color, not a warm color, not cool color, nothing. Okay, so I'm going to write achromatic. Another word for achromatic. Does anyone know another word for achromatic? No color. It's one of the words we use all the time when we're behind the chair. Neutral, yes. Brittany says neutral. When you create something that's neutral, you are subtracting all the waves. You're taking away a color. So now, is neutral reflective or is neutral flat? Tell me in the chat box. Neutral, is it reflective or flat? Neutral, flat. Yes. So achromatic, meaning, oops, chromatic. I can't spell and talk at the same time. Is anybody else like that? Achromatic equals no split, no color. Also known as neutral. So someone said it earlier, neutral is at the center of the color wheel. We'll get to that in a little bit. I love it. Good. All right, what questions do we have so far? Are we good? Alicia, I can't see if there's any hand raised for questions or not. So
not at this time, but you guys feel free.
Yeah, feel free, because I want to make sure you capture. Color is energy. What did you say about making something neutral? Beautiful. So here's the thing. When I see orange in the hair, who likes orange in the hair? Not if it's not on purpose, right? Okay. So orange means that the orange light is just reflecting. So here's what we do. In order to fix that, we don't want to see orange. We add pigment. What do we add? What color do we add? Brittany says blue. So everybody in agreement, we add blue, right? Well, guess what blue does? Blue is subtracting, it's pulling in the orange color. Neutralizing, meaning it takes away any light reflection. When we neutralize, we're taking away anything that's reflecting. Good? So as colorists, we're dealing with light reflection. We add pigment to see a color we want. Here's how we do it. There's gold in the hair. I don't want gold. I want to see copper. So I'm going to add a pigment to her hair that's then going to reflect copper. We call it copper. If I want to reflect copper, I put copper in it. It's going to reflect copper. Or if I have orange in the hair and I don't want to see orange, I add pigment into the hair that will take that away. So we're either reflecting color we want to see or taking away color we don't want to see, all by adding pigment, light absorbers or light reflectors. That's what we do as colorists all day long. We play with light reflection. That's our job. And in order to do that, to add the correct pigments, we have to understand color. We have to understand the color wheel. We have to understand the concept of color, how colors relate and respond to one another. And so that's called color theory. How do I use this pigment to get it to look the way I want it to look? So here's the cool part about color. When this white light comes down and then there's a wave that reflects, that color has 3 properties to it. It's not just one. It's got 3 properties to it, or 3 dimensions. So when we see a color, here's what we do. We're gonna, number one, the first property to that color that's reflecting is called the hue or the color. So the first thing when I'm looking at something as I go, okay, what color is it? Pretty simple, right? So I'm gonna go around my color wheel and I'm gonna say, I see the color orange. I've identified that piece of my color. The second property of the color is light to dark. What do we call light to dark in our business? What's a word we use? Level. Another word for light to dark is what level is it? So first property is, okay, I see the color orange. The second thing is, well, is that orange a level 7? Or is that orange a level 6? Or is that orange a level 4? Like, this is how we define what we see. And then there's a third property to color. The third property, this is a new one for our business, so we don't talk about it a lot, but it exists. And it's called saturation. Okay, so let me show you saturation. We've already identified it's copper. Let's pick a level 6. Okay, let's identify it as a level 6. And then the third property is, so here's a level 6. Is that 6 vibrant and strong and pure? Is that 6 blended, half pure, half muted? Or is that level 6 really muted and dull or natural looking? In our world, a natural copper would be a brown copper. Does anyone have a tube of color called BC or brown copper? That means that there's not a ton of copper in there. There's a lot of mutedness and a little copper. This one might be 50% copper and 50% of a base. This one is like our fashion shades, pure copper. Is everybody with me on that? So there's 3 properties to every color that you see. How do you determine saturation without confusing level? That's so interesting. It is kind of tricky, isn't it? Here's why it's tricky. Because if we look close, let's say this is what we're looking at. Do you see the color that is outside here, real bright? Does it appear lighter than the color that's muted? Yes or no? Yeah. Yeah, it makes you think that it's lighter, but it's not. It's actually just purer. And honestly, I'm going to be honest, it takes time. It just takes time. The really cool part about what we have already is, if I pull a tube of color, it gives me 2 properties already. It tells me what color it is. 6 ash, 6 copper, 6 red violet. It tells me my hue. They also tell us our level, don't they? A 6 BC brown copper, a 6 copper, right? Don't they tell us? The third property is what we generally don't know unless we swatch out our colors. And we can talk about that at another time. So does everybody understand? Identifying a color fully is naming those 3 properties.
Julie?
Yes.
So Brittany asks, I'm sorry, not Brittany. Yeah, Brittany asks, so but muting it make it darker will mean that it's darker.
It will make it less vibrant.
Okay.
Will it make it darker? Depends on how you mute it. If I add a level deeper, yes. Just because it's muted doesn't mean it's necessarily darker. Think about, like, if you have in your color line a brown copper at a level 6 and you have a copper copper, are they both labeled a level 6? Yes or no? They are. So that tells you the levels are correct. One will look more vibrant to the eye. One will look duller. It will appear deeper. But is it technically? No. It's the same thinking when we have a 6 ash or a 6 copper, right? Yes, it reflects more light, Brittany. Imagine, here's how I want you to view it. So imagine a color. Let's do it this way, Brittany. This might help a little bit. All right, so let's do 2 cups of color. This color is going to sit on the outside of my color wheel, be really pure. So everybody get that? So this is pure. Really vibrant, really strong, really bright. This one will be blended. Okay? So I want you to imagine, this is purple, but try to imagine this is copper, okay? In my copper, level 6, this is my copper, 4, 5, 6. So it's got pigment in it that reflects only copper. So now my blended color, here's what I want you to imagine. It has the same amount. These are copper, copper, copper. These are achromatic, 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 meaning the amount of pigment is the same. This one will reflect only copper, so it'll be vibrant. This one will reflect 3 coppers, but 3 of them will absorb all the light. So when we look at it, will it be copper? Yes or no? Tell me in the chat box. Will the color still be copper? Yes, yes. It's a muted version of copper. That's saturation. They're both a level 6. They're both copper. Got it? Good. Okay, good, good. Awesome. So here's what we need to know. Once we know our color, we can work with it better. If I only know that it's orange, but I don't know much about it, I don't know the level, I don't know how pure or not pure, do you think that's easy to work with that color? Do you feel like you're going to be missing pieces? Yes, if you feel like you'd be missing pieces in the chat box. Yes. Yes. So understanding color is way more than looking at a pure color wheel and saying, oh, I have orange, I need to use blue to cancel it. Well, you're missing pieces. How blue is it? How level saturation? And what is the third? Hue. So hue, Mary, is what color is it? So I'm going to take this color wheel and I'm going to go around the color wheel and say, what color do I see? Is it red? Is it blue? Is it copper? That's what I'm going to do first. The second thing I'm going to do is let's pick orange because we kind of went with it. So here's my color wheel. I'm going around. I see orange. So now I'm going to say, well, how light is that orange? Or how dark is that orange? And then the third thing is, how vibrant or how muted is that orange? That's fully identifying the color. If you do that, you have a better chance of working that color correctly and getting what you want as an end result. Is that good?
Quick question.
All right. Yes.
So Shannon asks, does that mean more saturation is on the outside?
Yes. Here's what I want you to think, Shannon. I want you to think outside of the color wheel, fashion colors, vivids. And then I'm gonna go in and I'm gonna say, this is a very reflective color. Has anyone heard that? This is our reflect line. And then I have a blended color, 50-50. And then I have a very natural looking color. This is how, here's the deal, you guys, behind the chair, when we work with permanent color and demi-permanent, we're not working on the outside of the wheel, are we? No, we're working somewhere in here. Our job is to figure that out because they don't tell us that part. Okay. So here's what I want to do. Because remember, I said we're going to take a slice. We're going to take hue. We're going to take that first category, hue, and we're going to break it down into all of its parts so that we are really equipped with understanding hue. And then we're going to learn how to move hue on purpose. Okay, so we're working with color in its purest form. Think fashion color. Once you get that, learn this first. Learn how to work color in its purest form. Then add level. Then add saturation. Remember, we talked about like taking a slice of the pie today. We're not going to take the whole thing. Because if you can get hue, learn how to move it with purity, the rest is easy. Okay, is that good with everybody? So let's take our color wheel and let's, we're going to divide it into all of its parts. Perfect. All right, this, you guys, is easy because this is what we're most familiar with. So what's the first color that we learn about? When we look at the color wheel, we're going to divide it into its categories. What's the first category we generally learn about in like kindergarten, elementary? Primary colors, yes, primary colors. So here we have, I'm going to turn this a little bit. I don't know about you guys, but I have a certain way I like to look at the color wheel. I'm kind of weird like that. Okay, so we have yellow as a primary, we have red as a primary, and we have blue. All right, here's how I'm going to describe the primaries. A lot of times we hear primaries are colors that cannot be made from other colors. Well, if you study color enough, you know that you can actually create red from magenta and yellow. So we're not going to say that. We're going to say primaries are the colors that we begin with, the colors we start with. And they're right now, they're one part, yellow, Y, R, red, R, blue, B, one part. Okay, so what's the next category we learn about after primaries? So primaries then comes what? Secondary, yeah. The secondaries, do you guys remember, how do we make a secondary? We mix two what together? Tell me in the chat box, what do we mix together to get a secondary color? Primaries, beautiful Mercedes, yes, two primaries. Here's how that works. I'm gonna mix my red and my yellow, and I'm going to get orange. Yes, Brittany, oranges are Y. So RY. Secondary colors, we're going to call them two-part colors, R and Y. Now, between my yellow and my blue, what's my secondary color? What do you got for me? Green. Yes, green is a B and a Y. It's another two-parter. Now, can you make green with a different ratio of B and Y? Yes, you can. But remember, today we're in basics. So let's just call it two-part colors and be good with that, okay? So now I have another secondary where I mix my B and R, and what does that give me? What does that give me if I mix B and R? Violet, yes. Not purple, you guys, violet. Violet and purple are different colors. So B and R. We feel good about that, yeah? All right, let's move on. What's the next one that we learn about? This is probably the one we're not as familiar with. Tertiary, yes. And what do I mix together to get a tertiary color? What do I mix? Secondary plus a secondary and a primary, exactly. So here's what I'm going to have. I'm going to have 3 tertiaries on the warm side, and I'm going to have 3 tertiaries on the cold side. So here's what I'm going to do. Right up here, I'm going to mix YYR. That's going to give me gold. Everybody write this down. Gold, YYR. Is there red and gold? Yes or no? YYR, is there red and gold? Yes, there is. You got it. Then I'm going to come down here and I'm going to mix the next two and I'm going to get an RRY. That's copper. Copper is not RY. That's orange. Copper is heavier on red. So copper is RRY. Write that down. You're going to want that for later. Then I'm going to come down here and I'm going to have a BRR. Is everybody seeing where we're getting this from? Does everybody feel good about it? All right, so then we're going to move on. Here we have a BBR. So that's blue violet, blue violet. Oh, let me tell you this. BRR is a red violet. Oops, I wrote that wrong. Hold on. Let me change this for you guys. We'll do it this way. RRB. Why did I do that? Because primary is always supposed to come first. So RRB is red violet. Has anyone heard of the word mahogany before in your color? Yes, mahoganies are red violets. They're a browner version of a red violet. This one we said was a blue violet. And then the next one here is a blue green. Yeah. And then I'm going to just say this for time's sake, but this one is a YYB. YYB is yellow green. Okay. So can everybody see that okay? So now we've labeled everybody. Tertiaries are 3-part color, secondaries 2 parts, primaries 1. Now here's what we also understand about the wheel. The wheel is divided in half. It has a warm side and a wet side. A warm and a wet. Type it in the chat box. Warm and cool. Our colors have temperatures. And then we have something that's in the middle. So we talked about something that's in the middle. Something that's in the middle can't be warm and it can't be cold, right? So if it doesn't have a temperature and it doesn't have a warm color or a cold color, what's in the middle of the color wheel? Neutral, achromatic, yes. For you and I right now, I'm gonna put gray, or no, neutral, but neutral is either gray, black at the lower levels, lighter gray at the higher levels, and white all the way at the top. So I'm gonna put N, but you all know N means neutral, no tone, no color, not warm, not cold. Good? Okay, so another piece of this cat, we're gonna break the categories down one more piece, actually 2 more pieces. There is something called analogous colors or harmonic colors. Those are colors that sit next to each other on the wheel in pairs of 3s and 4s. So here's a great set of analogous colors: gold, orange, and copper. Analogous colors support one another. If I'm at orange right here, and I want to soften the orange, I don't want it as intense, I'm going to add the color above it. Gold will soften orange. If I'm at orange, but it's not as intense as I want it more intense in copper, then the color below it will intensify. So the color above softens, the color below intensifies. So those are analogous. We're not going to fight it. We're going with it. They support one another. And then we have another color we haven't talked about. Does anyone know what have we not talked about yet? Some people mistake this as the center of the color wheel. Does that help you? What color have we not talked about yet? Type it in the chat box. Brown. Yes, brown. Has anybody ever thought brown was at the center of the color wheel? Yes. All right, so let's kind of help you understand why brown is not at the center of the color wheel. All right, I'm going to tell you what the formula, the universal formula for brown is. Brown is 1B, 2 R's, 2 reds, and 3 yellows.